Hello everyone. In this video I'll be talking with you about a BJT model equation derivation. So this is a model of a BJT, bipolar junction transistor, that we have here, and we have at our top node here VCC, at our very bottom node we have ground, and to summarize the rest of this, we have R1 over here, R2 over here, then we have RC and RE. This is IB, this is IC, and this is IE. So the model of this includes a current-controlled current source, which is in the branch of IC, and it's based upon IB. So the scalar here that we have for beta is just scales up IB, and that's actually what IC comes out to be. Then we have V sub 0 here, which is just like a barrier voltage in order to basically turn on the transistor and to be able to get these things going here, to get current flowing there. And IB is here again. So the goal of this problem is to express IB in terms of R1, R2, RE, VCC, V sub 0, and beta. I made a special note here that VB minus VC equals V sub 0, and that can be rearranged for to say that VB equals V sub 0 plus VC. And that'll prove to be something that will help us and actually is essential for our analysis and derivation that we have here. So I'll go ahead and I'll start with on this side over here on the left hand side, I'm going to use KCL, Kirchhoff's current law, and I'm going to make a statement here. That statement says I1 equals I2 plus IB. Next, I can make another current equation for what's going on over here, and that's just generally saying that, well, IC, or let's just say IB, going in there, IC is going in there too, so IB plus IC equals IE, what's coming out of there at node C. So first we made an equation based off of what's going on at node B, and then next we made another equation based off of what's going on at node C. Now, next thing we're going to do is state this in terms of voltages and resistances, these current relationships that we have here. And so I1 is what? VCC minus VB divided by R1, and that's equal to I2. Well, what's I2? I2 is VB minus ground, which is 0, so we can just go ahead and immediately simplify that. So that's VB over R2, and we'll just leave IB as it is, because again we want IB in this equation. We don't want to eliminate it. We want to express things in terms of IB. So at the end of all of this is going to be IB equals this, this, that, and this, but in terms of these. Now next, again we have IB, we're going to leave that in there, plus IC. Well, IC is equivalent to beta times IB, which is our current-controlled current source over here on our right-hand side. And that's going to be equal to IE. Well, what's IE? IE is VC minus ground, so ground is 0, so we'll just automatically simplify that. So it's going to be VC divided by RE, and that's what IE is going to be. So next, what we'll do is we'll take a look at our equation here and analyze it. What do we have and what don't we want? What do we want to eliminate? We want to eliminate VB and we want to eliminate VC. So let's go ahead and start with VB first. which is basically what I wrote out here, down here. VB is equal to V sub 0 plus VC. And we can go ahead and we're going to substitute that in for VB, and then we'll only be left with VC to eliminate. So I'm going to separate and say VCC minus VB over R1 equals VB over R2 plus IB, and IB, and I'm going to factor, is 1 plus beta. Okay, IB times 1 plus beta equals VC over RE. Next, I'm going to go ahead and make the substitution for VB. And so now we have VCC over R1 minus VB, which is what? V sub 0 plus VC over R1 equals, again, VB. What is VB? V sub 0 plus VC over R2 plus IB. And so for our other equation over here, what I'm going to do is eventually we're going to want to eliminate VC. So I'm going to state VC in terms of these variables here, which are things that we do want in our equation. IB, beta, we can see here IB, beta, and RE is there. So now we have IB 1 plus beta times RE equals VC. And so that's the very next step that we have now. And we'll go ahead and we'll make the substitution for VC. But before we do that, let's go ahead and expand a little bit more. VCC over R1 minus V sub 0 over R1 minus, have to distribute that negative in the front there, minus VC over R1 equals V sub 0 over R2 plus VC over R2 plus IB. And the equation again that we're going to be using here in our substitution is IB times 1 plus beta times RE equals VC. And so let's go ahead and make that substitution now. And we end up with VCC over R1 minus V sub 0 over R1 minus VC. What is VC? It's IB. And I'll just bring RE over here to the front. IB RE 1 plus beta. And that's going to be divided by R1. And that's equal to V sub 0 over R2 plus VC again. Well, what is VC? It's IB RE. I'm just bringing that over to the front. 1 plus beta. And that is over R2. And we have plus IB. And so thus far, this is what we have. So I'm going to be erasing so I can make more room and continue on with this derivation that I have here. So just give you a quick moment to see what I have there in case you need to take a look at it, pause the video or whatever. Okay, so now I'm going to make more room here, and we're going to continue on. Now take notice of the fact that we've eliminated VC and VB. We eliminated VB first. Now we've eliminated VC. So now the goal is to basically separate and be able to state IB in terms of everything else. So it's going to be IB equals this, that, this, and this, and that's going to be our ultimate goal. So next, what I'll do is I will bring over and group up together everything that contains IBs on one side and everything that contains something else on the other side. So now that brings us to VCC over R1 minus V sub 0 over R1. I'll bring this one over to the left side, minus V sub 0 over R2 equals, I'm going to bring this over to the right side, and that is IB RE 1 plus beta over R1, that's added to IB RE 1 plus beta over R2, which is already over here, and we have plus IB here. And so next what we're going to do is let's go ahead and begin to factor this part out here and factor here as much as we can. But before we factor, let's go ahead and add these up. So now we have VCC over R1, and we have minus V sub 0, okay, and we have 1 over R1 plus 1 over R2. Okay, so actually I'll just go ahead and write that out. 1 over R1 plus 1 over R2, and just do that in the next step. So next here, we have things that are like here, but ultimately we want to isolate IB. So we're going to factor out IB. So now we have IB times RE 1 plus beta over R1 IB, I mean not IB, but RE times 1 plus beta over R2, and that's plus 1. So next what we'll do is let's go ahead and add these up. So now we have VCC over R1 minus V sub 0, and in order to add them up, I'm going to use our algebra skills that we have here, and we're just going to multiply on each one of those sides, and the common denominator that we're going to have is R1 times R2. In order to get that, multiply R2 over here, so that's going to be R2 plus, what do we need over here in order to make that true? R1. And so now then we have IB, and so the very next thing we're going to do over here is start to add all of this up, and the common denominator that we're going to have here in order to be able to add this up is R1 times R2, just like what we have over here. And so now we have RE 1 plus beta, and we have a R1 here. What do we need? A R2, so that's going to be there. RE again, 1 plus beta. We have a R2 here. What do we need? A R1. And then over here, we're going to need both R1, R2. Running out of space here, getting kind of cramped. R1, R2, there on the bottom. So that's what we have there. Next, I'll go ahead and I'll actually add this up as well with it. I'll distribute this inward and add, well actually I don't even need to do that. What I'll do is we have our VCC, and the common denominator is R1, R2, and so VCC needs to be multiplied by R2. We'll have negative V sub 0 times R2 plus R1, and that will all be over R1, R2. So I multiplied R2 over here, then that made it compatible for addition. And so I just made sure that I kept this relationship here with negative V out, V sub 0 that is, negative V sub 0 times R2 plus R1. Okay, so then next what we can do over here is we're going to start factoring. That's equal to IB times, we have 1 plus beta and RE. And we could go ahead and factor that. I guess I will do that. That'll be less writing at the very least. So we now have RE 1 plus beta times R1 plus R2 plus R1 R2, and that's divided by R1 R2, and so we have that now. Now what we're going to do is finally we have IB isolated by itself. Actually we had it from here, but now this is in a better form, and we're going to multiply by the reciprocal of this on both sides. Now when we do that, take notice of the fact that R1 and R2 is going to be on the top over here when we multiply that factor itself, and that's going to cancel out R1 and R2 over here on the bottom. So effectively what we'd be doing overall is we would just be taking this and putting it on the bottom over here. And so that's what we'll have in our next step. So now we have VCC times R2 minus V sub 0 times R2 plus R1 divided by all of this RE times 1 plus beta R1 plus R2 plus R1 times R2 equals IB. Ultimately, this is what we want to end up with. This is absolutely correct, but we can go ahead and put it into maybe a possibly more favorable form, but this is the result of our equation derivation here, so that's successful enough. But I'll go ahead and put it into a final form that will maybe be more conventional to put it in. That means dividing out by R1 plus R2. And so VCC times R2 over R1 plus R2, that right there, minus V sub 0. Now that came out, and that's being divided by RE times 1 plus beta. That cancels out, that comes out there, plus R1 times R2 over R1 plus R2. And all of that equals IB. So let's go ahead and I'll just outline that there. Let's go ahead and backtrack and make sure that what we have in terms of, we have IB, which is here in terms of what? R sub R1, R2, we have R1s and R2s there. RE is there. We have VCC, which is there. We have V sub 0, which is here. And we have beta, which is here. And nothing else. So that completes it for this particular problem that we have here, where we're using a BJT model and we've derived the equation to express IB in terms of these particular circuit variables here. And so that completes it for this video. Hopefully it was helpful to you. Thank you for watching and have a nice day.